No, you're thinking of an amp. The way I see it is, there's a couple of different ways you could define Coulomb. So for example, you could define it as maybe multiples of how much charge there is in one electron. There's also other definitions too. Actually, do you have your electricity book there? Give me it here. All right, let me have a look at some at the back here. Define the Coulomb. So I guess any definition of Coulomb would do. Let's get some definitions from the internet to see. You see, one way you could define it, where's your electron button here? Shift 7, tron charge, that's E. Where's E? There, 23. That's how much charge is in 1 Coulomb. 1 electron. So like, what you could say is, you could say 1 Coulomb, this is number 7 now. 1 Coulomb is the charge of reciprocal X. What did you say? Avogadro's number is
6.67 times 10 to the power of 20.
Oh no, it's not. I remember you trying to give me some definition of Coulomb with moles and electrons.
Like the number of moles of electrons.
Yeah, there's going to be a few definitions. Anyways, what I could say, 1 Coulomb is the charge of 1.24 times 10 to the 18 electrons. I don't know, that doesn't seem like a great definition. What did they go for in the book there, Brendan? And I'll get something online as well.
A coulomb is the quantity of electric charge that passes when a current of 1 ampere flows for 1 second.
Oh, that's and also another lazy definition. Here, let's get some serious definitions here. Define Coulomb. See, I'm not too keen on that definition because I define amp as 1 Coulomb per second. So then I can't also then define a Coulomb as 1. Yeah. Oh, okay. I guess I should be changing my definition for amp because a Coulomb is defined as the charge in 1 second by a current of 1 amp. So that's another definition. So we have 1 here, 2 here. The charge carried in 1 second by 1 amp.
Then what's the definition of
It's the one I really don't like that involves like 2 infinitely long metal wires 1 meter apart in a vacuum and there's this much force produced. It's a very I suppose I could say contrived definition.
Kids that are like in year 7 are taught this.
Yeah, so Wikipedia, you give us some more definitions, please.
Find out.
In the SI system, a Coulomb is defined in terms of amps and seconds. Alright, so then let's go with the definition of amp then. You got it there too?
I'm checking it now.
And you see here, look, he also says 1 Coulomb or 6.241 times 10 to the 18 electrons. But let's see what else we go for. There you go, Brendan. There's my definition. That's another definition of an amp. So an amp is the amount of current you need so that when two wires carrying 1 amp is 1 meter apart, it produces this much force.
Okay, and what, 2 times 10 to the power minus 7?
Yeah. So since I'm saying it, I'll do it here. That is definition of a coulomb, and then a definition of an amp. We can't really say an amp is a coulomb per second because we used an amp to define coulomb. So then to define an amp, define amp. So to have 1 amp, what you need is 2 wires. They need to be 1 meter apart, and they need to have the same current in it, current I and current I. Now, if they have the same charge, the force will attract or repel. What would happen? Repel if they're the same. So there's a force here pushing apart here, and if the force between them is equal to 2 times 10 to the minus 7 newtons, then you say there is 1 current between them. Where do you think this formula comes from? Well, that would come from this one. You know, so, you just have to learn it.
Is that the constant K?
That K is in the book. Yep. What's Sean saying?
I can't understand the vision. That way.
This one?
Yeah.
Yeah, it's not great now. If you give us another pen, give us 2 pens. Yeah, just give us any pen. So, if this has a negative, if this has electrons moving through it, and this one has electrons moving through them, if I put them close together, there should be a force pushing them away, right? So if I put them 1 meter apart, and if the current is the same in both, and if the force between them is equal to this number, then we say we have 1 amp in each. I know, it's ridiculous. I know, I agree it's ridiculous, but there you go. So that's a definition of an amp. Also, an amp is 1 coulomb per second as well.
It's weird how coulomb is far more easier to comprehend
Huh? There's no way. I entirely agree. I'm not keen on this definition.
Like an amp is basically the same way as why we define centimeter as a centimeter.
No,
Electron fluctuating thing.
to me, my personal favourite, best way to define it is, I would define a coulomb. If I could choose, I would define a coulomb as this many electrons, okay?
Yeah.
Because electrons are universal. They can't be made different. Electron is an electron. So if I could, I would say 1 coulomb is this many electrons. And then if you said, okay, what's 1 amp? I would say, well, 1 amp is just 1 coulomb per second, and then 1 coulomb is just this many electrons. That's the easiest definition. However, this is the what you might call the technical definition. This is what you would have in like standard physics textbook. But this, I mean, that's ridiculous because look how small that is. You know?
Is that a value or anything? Like, is a constant number?
And where does this number come from? This number is chosen. So it seems very arbitrary to me. Anyways, I'm sorry, I just have to give you the definition like this as well. I'm apologizing for this, okay? Yes, yeah. Alright, let's just move on with our lives. Because at the end of the day, that was 1 mark. And it was only for a coulomb. So 1 coulomb is the current of 1 amp per 1 second, the charge. Alright, look at this. Determine the number of electrons in this much charge. So can you write this down? 2.36 times 10 to the minus 2.
And the charge of 1 electron.
Hold on. 2.36 times 10 to the minus 2. So it's 2.36 times 10 to the minus 2 coulombs. They want to know how many electrons are in this charge. So I'll just divide it by the charge of 1 electron, which is on your calculator and it's in the formula book. What was it? no, the mode of a calculator, what's it, shift 7 and then 23. Okay, and it's fraction 2.36 times 10 to the power minus 2. So it should be really big. Yeah, 1.47 times 10 to the 17. So that's how many electrons are in this charge. Okay? A current of 2.4 amps flows through a metal wire of resistance 28 ohms. Determine the power dissipated as heat. So this is how much power is lost as heat. So I don't know if you remember the formula for how much power comes out of a resistor in heat form. Now it might be in the formula book as well. There it is. I squared R. So he gives us the I and he gives us the R. Yeah, there you go. 161 watts. It's straightforward, 2 marks, just use the formula. The key is you need to know which formula to use. But if you think about it, he just gives us the I and he just gives us the OR. So if you look at the formulas, there's actually only one formula with P, I and OR in it. That's this one here. So you don't really have any choice.